Okay, so now that we're recording, just a recap. A negative number, absolute value, is always greater than a negative number, but absolute value is never less than a negative number. Okay, so remember our special cases. So this is that whole greater than piece. So if we have absolute value and we have a negative number, so here's our negative number and here's our absolute value. If it's greater, it's always going to be a solution. But if it's absolute value and we're talking about less than a negative number, it's never. Okay, I know I'm saying it over and over again, but it'll be the biggest place where you make mistakes. Okay, so here's our objective today. Students will be able to solve an absolute value inequality algebraically. So yesterday we did it graphically, right? And now we're going to do it algebraically. Same exact problem. I don't think we need any of this. Let's just get to it. Okay. So on this side, I need to, what was my first step again? Isolate absolute value. So this absolute value is currently being multiplied by 4. So in order to get rid of that, I'm going to divide by 4. When I divide by 4, I now have absolute value of x is less than 2. My next step is to set up two problems. I have x is less than, let's do this one first. X is less than 2, but on this side I need to flip the sign and say negative 2 because I just applied a negative. Make sense? Good. And we're done. That's it. So when I do my number line, I have a 2 and I have a negative 2. And x is less than 2 means it's going to be going this way. And x is greater than negative 2 means it's going to be going this way, which is significant with our sign right here that said less than, right? Matches. Now I'll do this one on this side. The same steps. I'm going to divide by 4, divide by 4. So now I have absolute value of x is greater than 2. Set up two equations. I have x is greater than 2, and I have x is less than negative 2. Flip the sign and change the sign. 2, negative 2. X is greater than 2 means it's going to go out. X is less than negative 2, so this way. And again, consistent with my great or sign. Malik. Not yet. Not yet. Soon. I'm recording, right? My dynamic lesson, and Malik wants to use the restroom. Okay. Questions so far? On this one right here? Okay, so I applied a negative, right? Because we were talking about on the positive side of the number line, we're greater than. But if I'm going to switch myself onto the negative side of the number line, wouldn't I have to switch the sign now? Because I would no longer be greater, I would be less than because I'm on the other side. That's when we're talking about when it's an absolute value, right? But with absolute value is the distance from 0 on a number line, right? The distance from a number on a number line, and distance is always positive. So we have to talk about the distance in the positive direction, and then we have to talk about the distance in the negative direction. Let's give you guys that visual again. So if I have the absolute value of x minus 2 is greater than 4. Okay? Absolute value of x minus 2 is greater than 4. If I have a number line, then we're talking about the distance between x and 2. So here's 2. So the distance between x and 2 is greater than 4. So 1, 2, 3, 4. There's 4 in one direction, and 1, 2, 3, 4, because it can be in either direction, right, the distance? So my answer would be 3, 4, 5, 6, or, and it says greater than 4. So it could be 6, or 7, or 8, or 9, or 10. And this way, it would be 1, 0, negative 1, negative 2, or negative 3, negative 4. I'm saying the distance between a number and 2 equals 4 spaces. So that's why when we go in, we have to go in each direction, because I've got to talk about a distance in this direction, and I have to talk about a distance in this direction. Well, when I went in this direction, I went on the negative side of the number line, and therefore I have to switch that sign, because this would be greater than, right? And this would be less than. I hope that helps a little bit. Okay. I know, it's a little bit abstract. So this one, what's the only difference that's going to happen in this one? The signs are going to switch immediately, right? So on this one, when I divide by a negative 4, as soon as I divide by a negative number, this is going to become greater. So now I have absolute value of x is greater than, is absolute value of x, is positive always greater than negative, or never greater than negative? This one's an always. So let's see what happens when I have this always situation on a number line down here. So I'm going to, same thing, set up two equations. I have x is greater than negative 2, and I have x. Now I'm going to switch the sign, right? Because I need a positive sign. Less than positive 2. So I've got 2. And we're talking about x is going to be less than 2. And we're talking about x is going to be greater than negative 2. So what do you see that happens? They overlap. What happens when something overlaps like that? X is an element. All real numbers. Just like on the graph right here, when this function, when is this function less than 8? When is the function right here, right? When is this function less than this line? Always. So that's a graphical representation. Right, Jaden? Yes. Well, graphically, you can see it overlapping. I'm talking about all the numbers that are smaller than 2, right? And all the numbers that are bigger than negative 2. Doesn't that mean all the numbers on the number line? Does that make sense? So if you just graph it, you can see it. They're overlapping. Okay? All right, so I'm going to do the other side really, really quickly. And you'll get to see this one. So I'm going to divide by a negative number. When I do that, that sign is going to switch. And so I have absolute value. Change my color. Absolute value of x is less than negative 2. Let's look what it does graphically. Okay, so this is the one that's tricky because it's going to give you a graph, right? But we know that absolute value can never be smaller than a negative number, right? Absolute value is positive, so positive could never be smaller than negative. So this is no solution. So this is the trickier one. It's going to give us something on the graph, but you've just got to know that absolute value can never be smaller than a negative number. I think we just need practice, right? Awesome. So I think, can you guys get some whiteboards out for me? Perfect. Perfect. I will get that for you. Recording. All right, I'll do the first one real quick. Okay, so first thing I'm going to do is I'm going to get rid of this 1 by subtracting 1 from both sides. I'm left with 1/2 of the absolute value of x plus 5 is less than or equal to 2. I need to get rid of this multiplication out here, so I'm going to multiply both sides by 2. That gets rid of that. So I'm left with absolute value of x plus 5 is less than or equal to 4. Now I have isolated my absolute value, so I'm going to set up two equations. X plus 5 is less than or equal to 4. Ooh, that doesn't look good. And x plus 5, flipping that sign. So now instead of less than, it's going to be greater than or equal to negative 4. Let me move my little number line down. Uh-oh. That's better. So when I solve this, this is going to be subtract 5, subtract 5, subtract 5, subtract 5. So x is greater than or equal to negative 9, and x is less than or equal to negative 1. So I have negative 9, negative 1. This is the only time right here where you have to worry about negatives on this side, right? When you've got absolute value. Once you split them, we're not worried about that anymore because it's not absolute value anymore. We've already split it, okay? We've already talked about going in both directions. So this is the only spot right here that's critical, right there. All right, so let's see. X is greater than or equal to negative 9. Greater than or equal to means I'm going to fill that circle in, and I'm going to go greater. And less than or equal to negative 1 means I'm going to fill it in, and I'm going to go less than. So it should be, and which is consistent with this, absolute value is less than. Less than means we're going to talk about everything that's including an intersection. Andrew. Ask me again. The one on the left. This one? How did I flip the sign? So we're talking about going in the positive direction. It stays exactly the same. Well, when I'm talking about going in the negative direction, because remember when we were solving equalities, absolute value equalities, we would talk about the positive direction, and then we would switch the sign and talk about the negative direction. Well, since I switched this sign right here, since I switched that to a negative, I had to start talking about it the opposite way. So if this is less than, when I talk about the negative side, I now have to be greater than. And if it was the other way around, if this was a greater than sign, it would stay greater than when I talk about it in the positive direction, and then it will be less than when I talk about it in the negative. So you're just switching the sign when you apply that negative. Any more questions? All right, let's see what the graph looks like. Is it consistent? Because this is your graph from yesterday on this problem. So here's my absolute value right here. And it's talking about when is it less than 3? Here's 3. Here's my graph. When it's less is in between. You did this yesterday. You don't have to do that. Is in between here. So in between negative 1 and negative 9. Looks like it's actually right there. Uh-oh. Sorry. I promise I'll go faster. So there's my negative 1. there's my negative 9. And we're talking about everything in between. So everything's consistent, all matches. Thumbs up, thumbs down. How are we doing? I need everybody's opinions. How are we doing? Thumbs up, thumbs down, thumbs sideways. Yeah. Yeah, kinda. Kinda. There. Like that? Okay. All right. Looks like we're all kind of right there. All right. Can you guys do this one for me? Yes, I'm sorry. Pausing. Okay. All right. So the first thing I'm going to do is I'm going to get rid of the 6. I'm going to subtract 6 from both sides. Then I have negative 2 times the absolute value of x is greater than 0. I need to get rid of that negative 2, so I'm going to divide by negative 2. Once I divide, instead of this being greater, it's now going to be less than. All right, so absolute value of x is less than 0. Can absolute value, so absolute value, let's ask ourselves, this has got to be a positive number, correct? Can a positive number be less than 0? Can a positive number be less than 0? This is no solution. If it was less than or no, can a positive number be equal to 0? What are all the positive numbers on the number line? 1, 2, 3, 4, going into infinity. So can a positive number be 0? Just considered 0. All right, this was a good one to do. You have to think, inequalities, you have to think about it. When do you make that consideration? When your absolute value has to be isolated. You can't make that decision here. Everybody look up here. You cannot make that decision here. The decision has to be made when the absolute value is isolated. Then you can consider whether it makes sense or not. Okay? All right, let's try another one. Another one with negative. So we've got to think about it, right? It's going to be a negative number on the right-hand side. Okay. So I'm going to get rid of the 6. So subtract 6 from both sides. Subtract 6, subtract 6. Then I'm left with negative 1/5 times the absolute value of x is less than or equal to 1. Then I'm going to multiply both sides by negative 5. That gets rid of this. So now I have the absolute value of x is less than or equal to, sorry, I'm multiplied by a negative, so I got to switch that sign. Negative 5 is a pause. Now I'm at that crucial point, right? I've got to figure out whether or not this makes sense right here, because the absolute value is now isolated. So is a positive number going to be greater than a negative number? Yes, a positive number can be greater than a negative number. So I'm going to go, if I say, okay, I can go ahead and split my two equations up. So I have x is greater than or equal to negative 5. And then I'm going to go in the other direction. X, that means I got to switch my sign, is less than or equal to positive 5. Other direction, opposite sign, right? So now we're going to graph it. So I'm at 5, and I'm also at negative 5. What's happening at 5? X is less than or equal to 5. So less than or equal to is less, right? And x is greater than negative 5. Greater is over here. What? We go up to 7. So this ends up being all real numbers. Let's look at the graph. If you're ever confused about this, you can always go back and look at it graphically. So it wants to know, when is this function? I think it's so much easier to visualize graphically. When is this blue function less than the red line? Always. It's always less than it. And that's what makes it all real numbers. That's the nice thing about looking at this graphically and algebraically, because some of it's going to make sense to you more algebraically, and some of you it's going to make sense more graphically, but I like that you can compare the two and then see if you're right. Okay. Let's see. So why don't you look at your homework, and if you want me to do any of them, I will. Sorting. Okay, I'm going to do number 13. Let's take a picture of it. Make it big. All right, so the first thing I'm going to do is I'm going to subtract 2 from both sides. That gives me 2 times the absolute value of x minus 3 is less than or equal to 4. Divide both sides by 2, and I get absolute value of x minus 3 is less than or equal to 2. Why am I talking over people while I'm recording? This is 13. All right, now I make my decision. Is it a positive absolute value? Can it be less than 2? Yeah, a positive number can be less than 2, right? There's 1. So this is where we make that decision. So since we're good, there's going to be solutions to this, right? So now I set up 2 equations. I have x minus 3 is less than or equal to 2. And then in the negative direction, I have x minus 3 is greater than or equal to negative 2. Switch the sign, switch the sign. Just like we did algebraically with the equal once, right? It's the same thing. The only thing that we're changing is we've got an inequality sign that we've got to change. So add 3 to both sides, and I get 5. Look, time flies when you're having fun in math class, right? Add 3 to both sides on this side, and it's positive 1. So this is 5, and this is 1. X is greater than or equal to 1, or x is less than or equal to 5. So it could be any of the numbers in between there. And we're done.